This is our last video on the electrolysis topic. This one is about the electrolytic purification of copper. Okay, so let's start right at the very beginning. So copper is fairly low down the reactivity series. It's beneath carbon but above gold and silver. How would you expect to find copper in the earth? Well, copper in the earth, like most metals apart from gold and silver, is going to be joined to oxygen. So it's going to be copper oxide, okay, in the earth, okay. People would call that copper ore. So the first thing we have to do is we have to remove that oxygen. How would you produce copper metal? We've got to reduce the copper oxide, And you may be thinking to yourself right now, electrolysis will do that. And yes, it will. It would do it very well. We'll reduce the copper oxide. Having said that, electricity is expensive, and so the way they do it is do it a cheaper way. They're going to do a displacement reaction with carbon. Okay, because copper is beneath carbon, so carbon's above copper, so it will take the oxygen away from the copper because the most reactive element always takes the oxygen. Carbon's more reactive, so we end up with carbon dioxide leaving copper on its own. So we're going to reduce the copper oxide by smelting. It's called smelting. We heat it up with carbon. Smelting with carbon. Now we will do more about metal extraction in another unit. And that's what they do. So they get copper that way. Now the copper they get that way is not that pure. Okay, it's copper on its own, so it's not joined to oxygen, it's not copper oxide, but there'll be other impurities in it. Because basically the copper oxide is dug out of the ground. There might be some other metal ores in there as well. So we have impure copper. Now, we mainly use copper for wiring, and we don't want impurities in it because impurities might increase the resistance, so that might make the wiring get hotter, and that, I suppose, could lead to fires. So we want to use pure copper. So we have to purify the copper made, and that's where the electrolytic purification of copper comes in. Okay, so we've got a diagram before and after here. So this is the before. So we'll just set up our experiments here, and this is it after the experiments run for a while, or this process has run for a while. Label the diagrams with the following labels. Okay, first thing to notice is this is our impure copper. This electrode here is our impure copper. Now we do need to have a very thin, pure copper electrode the other side. So the first thing we have to decide is which electrode is going to be which. Okay, we've got the anode and the cathode. The cathode is the negative electrode and the anode is the positive electrode. Okay, what we're going to have here is we're going to have, these are going to be in a solution of copper ions. And that solution of copper ions is going to be copper sulfate. This is going to be copper sulfate here. Okay, and that's our solution of copper ions. Now, copper ions are Cu2+, so let's put some Cu2+ in here. Cu2+. Okay, so we've got, and this electrolyte is a liquid, so these ions can move. These copper 2+ ions can move. So the question, okay, which should we make the positive or the negative electrodes? Well, we want copper to be plated over here on the pure copper side. We want to make pure copper. So which electrode, so we want to attract these copper ions to this electrode. So should this be positive or negative? Well, this is a positive ion and opposites attract, so this is going to have to be the negative electrode. The negative electrode is the cathode, so let's label that the cathode. The anode is the positive electrode, so that has to be there, that's the anode. Okay, so we've now labelled those correctly. Negative electrode and positive electrode, we've labelled those as well. Copper sulfate, we've added down there. Copper and copper. Well, both of these are copper, okay? Both these electrodes are copper. Now notice, copper when it's an element is not charged. Copper ions in solution are charged. These are Cu2+ ions. Now the impurities. The impurities, hopefully you can see it in your book, you may not see it in the video, there's dots. There's dots in here. So we've got impurities actually in that copper, and that's what we're trying to get out, impure copper, okay? And at the end of the process, you see these dots, they're down here. These are the impurities at the end of the process, okay? And now we need to explain how we get from here to here. Because if you notice over here at the end as well, the pure copper electrodes, this one, is almost dissolved away completely. The pure copper here has thickened up greatly. So we've taken the copper atoms from this side and sent them over to this side. That's why that one is fatter. That electrode is fatter. That's the negative electrode. That's the positive electrode. Okay, so to understand this, and we'll start to write about this on the next page. Let's see if we can put that down there and maybe try and keep those diagrams in the shot as well. Okay, so let's do two subheadings. We're going to do the cathode first. Let's understand what happens at the cathode. Okay, well, at the cathode, that copper, when we turn the current on, that copper ion is going to be attracted there. So at the cathode, the copper ion, the Cu2 plus ion, now that's the copper sulfate ion, the copper ion in solution, so it's copper aqueous. It's going to touch that electrode, and when it touches that electrode, that copper ion is going to turn into a copper atom. Now, a copper atom has no charge at all. So how do we get from there to there? Okay, with 2 plus charge, it's going to need to gain 2 negatives to balance out those 2 positives. So it's going to need to gain 2 electrons. Okay, gain 2 electrons. So if we think about oil rig for a moment, oil rig, oxidation is loss of electrons, reduction is gain of electrons. This copper ion here is gaining electrons, so this is reduction. Reduction is happening there. And what we end up with is a solid copper electrode. So the copper ions in solution go to the electrode, touch it, and turn into copper solid. So that's what happens at the cathode. Now, if we had a carbon electrode at the anode, very simply what would happen is the solution would get less and less blue as the copper that was dissolved in it was precipitated on this electrode. But this isn't a carbon electrode, and this is why electrolytic purification is different from straightforward electrolysis. We have a copper electrode here, and this reacts. Okay, so we have copper atoms at that electrode. Okay, now the copper atoms, there's one, okay, dissolve into solution. So that copper atom there was a solid, and it says, I don't really want to be the anode. It says, I'd rather be in the solution and then head over to the cathode side. So the copper solid dissolves. And this is different to normal electrolysis because normally we use carbon electrodes and carbon does not get involved in the reaction. So the copper solid becomes the copper ion, and when it does that, it dissolves in the solution. So this was neutral, and now it's positive. How did it get to be positive? Well, it's got to lose negative charge. It's got to lose negative charge. So I don't really want to write minus electrons here because this is a chemical equation. We have reactants and products. If this is losing electrons, a product of this reaction is going to be electrons, so it loses 2 electrons. So oxidation is loss of electrons, so this one here is oxidation. Okay, so what's happening at this electrode is the copper atoms are dissolving. Now, these copper atoms were mixed in with impurities. Okay, the impurities drop to the bottom of the beaker. So the impurities do not get attracted over to the cathode side. They don't get attracted over to the cathode side. It's only the copper ions that get attracted over to the cathode side. The impurities drop to the bottom as the copper atoms that they were mixed in with dissolve. The impurities simply drop down to the bottom. You may think this is a load of rubbish to be scooped up and thrown away, but actually sometimes you find precious metals in here like gold or platinum. So actually these impurities, the chemists sift through these and get out some quite precious metals as well. So this is a great process for chemists.